Hi, my name is Roger. This is Mr. Rogers' Math Corner, where I help you solve problems you will definitely see in your class. So today we're going to do systems of equations substitution method. If you need to see the graphing, I link it over here. And if you need to see systems of equation elimination method, I've linked it over here. Okay, so I have two equations here. 2x minus 3y is equal to 1, and y is equal to x minus 1. Well, guess what? They've already given me the value of y. The value of y is x minus 1. There it is right there. So I could take this and I can plug it right in there or substitute it into the equation. And then what will happen is, even though we don't call this the elimination method, I will have eliminated the y. I'll just have an equation with x's, and I could solve any equation with one variable. So let's rewrite our equation now with the substitution. So 2x minus, now remember, you got to use the 3, all right? Because the y is x minus 1. That 3 is still there. So 3 times x minus 1 is equal to 1. Okay? Do you see that I plugged in for the value that it was y? Instead of minus 3y, since y is x minus 1, I write minus 3 times x minus 1. So now I'm going to do the distributed property. So I have 2x minus 3x plus 3, because that's a negative 3 times a negative 1, plus 3 is equal to 1. So now my next step is combine like terms. I have a positive 2x, a negative 3x. That is a negative x plus 3 is equal to 1. So to solve this, I'm going to subtract 3 from both sides. I get negative x is equal to negative 2. And remember, we haven't solved for x. This is negative x. So I have to either divide by negative 1 or multiply by negative 1 on both sides. So therefore, x equals 2. And once again, I've only solved for one of the variables. For systems of equation, you have to solve for both. Well, for y is x minus 1, and I already know what the x is. X is 2. So I'm going to plug that in. So y is equal to 2 minus 1, which of course is 1. So there is my solution, written like an xy coordinate. So my solution is 2, 1, and I have solved the systems of equation in the substitution method for these two equations. Okay? So this is one way that you see systems of equation. Sometimes you'll be given x equals 3, y equals negative 4. Just as easy. You're given the number, just plug it in or substitute. But this type of equation is also substitution. I have y equals negative 5 minus 17, and y is equal to negative x minus 1. Well, if y equals minus 5x minus 17 and y equals negative x minus 1, that means these two equations equal each other, right? If I say y equals this and y equals that, they must equal each other. So then you set them up against each other. So minus 5x minus 17 is equal to minus x minus 1. Okay? Because they both equal y, which is the same variable, they must equal each other. So set them up. So now I'm going to move things. I'm going to do a plus 5x over here, and I'm going to do a plus 1 over here. And so what do I end up with? I have 4x is equal to negative 16. So therefore, x is equal to negative 4. And once again, I've only solved for one of the variables. I have to solve for both of them. So I'm going to plug in my negative 4 over here. So y is equal to, now remember, this is negative 4. So negative is a positive. So this becomes 4 minus 1, which of course is 3. So the solution to this systems of equation is negative 4, 3. Don't forget, this was a negative x, and x was found to be negative 4. So you don't put negative 4 minus 1. It is a negative 4, which is a positive 4. Remember, negative make a positive. And so I write my solution as a coordinate, negative 4, 3. And that's how you solve systems of equations the substitution method. And now for the math joke of the day. What did 7 say to 8 when 9 walked into the room? Hey, look at the square. My name is Roger. This has been Mr. Rogers' Math Corner, and I will see you on the next video.